When we look for the domain and range, we'll start with the domain, which is the x values. So we're looking for those x values that have a corresponding y value on the graph. So the x-axis is the horizontal axis. So we're looking for some vertical line that hits the x-axis that also touches the graph. So over here at 5, there is no graph at x equals 5. So we can divide the graph into two pieces, this bottom piece and then this piece on the left side on the top. So where does that top piece begin? What is the smallest x value? Negative infinity. Good. All right. What is the biggest x value on that portion of the graph? 1. Negative 1. Is negative infinity part of the graph? I mean, is it? We can never capture that, right? So it's always a open parenthesis. What about negative 1? Negative 1 is included. Does anybody not know why that's the case? The closed dot means bracket. Okay? What about this other piece? What's the smallest x value in this portion of the graph? We start at 1 and we end with 4. So 1 comma 4. Is 1 included? Yes. So it's a bracket. Is 4 included? No. So it's a parenthesis. Okay, so that is the domain of that function. For the range, we're looking for the y values. So if I take my vertical line and I turn it into a horizontal line, now I run up and down the y-axis. Are there any y values that do not touch the graph? Yeah, there are a lot of them. There are a whole bunch right here in the middle, and then at the bottom there are a whole bunch more. So if we look at this lower piece, what is the lowest y value in that part of the graph? Negative 3. Because this horizontal line touches the y-axis at negative 3. What is the biggest number? Negative 1. So the first y part of the range is negative 3 comma negative 1. Is negative 3 included? Yes. Is negative 1 included? No. All right. Now for this upper portion, what is the biggest part of that upper portion? Or sorry, the smallest part of that upper portion? Right here at 2. And how far does it go up? All the way to infinity. So 2 comma infinity. Do we include 2? Yes, so it's a bracket. Do we include infinity? No. So those are the intervals for the domain and the range. So pull out your calculators. You need this worksheet up here if you don't already have one. I'll just throw calculators on the floor. Looking at number 1 in the warm-up, it asks, what are the x and y intercepts for the graph y equals 4x minus 32? Now, most of you probably know how to graph a line, but we're going to graph this on our calculator, and then we're going to use the calculator to find the intercepts. So, in your calculator, on the top left side is a button that says y equals. Push that button, and if you have equations in there, clear them out. And then you're going to type in 4x minus 32. The x button is this one next to the green alpha that says x, t, theta, or n. Anytime you're using a variable in this calculator, no matter what it is, x or t or theta or n, you always use that button, and it will always put it in as an x. Well, that's backwards, sorry. 4x minus 32. And then to graph it, you push the top right button, which says graph. And if you don't get this picture, I'll stop by and help you out. We are looking for the place where the graph crosses the x-axis and the place where it crosses the y-axis. So, is yours not working? Oh, okay. Syntax. Oh, you had a blank, a messed up.
Oh.
Let me see that. Oh, you were trying to graph plus.
Oh my gosh,
Okay, yours is still broken? Ooh. Okay. All right. So, where does this graph cross the y-axis? It hits at negative 32. How do you know that? Well, if you look at the equation, 4x minus 32, this is slope-intercept form. The last number gives me the y-intercept. The reason that's the case is the value of x on the y-axis is 0. So if I were to follow like -7, -6, all the way down, this is x equals 0. If there's any good way to erase that. So one thing you can do is plug 0 into the equation. Well, what is 4 times 0 minus 32? If I plug 0 in here, I get 4 times 0, which is 0, and the answer is just negative 32. And your calculator will actually allow you to plug numbers in. So push second, and then over here is a button called trace, and above it you see the words calc. So second calc, and there are a whole bunch of things the calculator will do for you. The first one is find a value. So click on value, and it says, which x do you want to know? Well, we want to know x equals 0. And it gives me the answer of negative 32. So do you remember back in pre-algebra or whatever you guys called it in junior high, and you had this big long equation and you had to plug in 7 and do all that math? Well, now you can just graph the equation, type it in, and put x equals 2, and it will spit out the answer for you. So if you want to know what's the value at 1, you just push 1, 28 at 2, and it will give you all of those numbers. Looking at the graph, we can actually see the x-intercept. What is the x-intercept? 8. Now, can we guarantee that it's 8, or is it just really close to 8? It depends. We don't really know. It's probably 8, but if I plug in 8, if it is 8, what should I get when I plug 8 into the function? I should get 0. And that's what I get. 8 comma 0. So the y-intercept is negative 32, and the x-intercept is 8. Let's graph the second equation. Negative 6x plus 8. Graph. Okay. What is the y-intercept? 8. You can get that from the equation. The constant of the equation is positive 8, so the y-intercept is 8. Now that doesn't always work. Look at number 6. Number 6 doesn't have a constant. Number 7 does not have a constant. Number 8 does not have a constant. So if it's a polynomial, all you have to do is read off the last number. If it's not a polynomial, then you actually need to plug in 0. And remember, to do that, you just push second calc. We want to find a value, and the value we're looking for is 0, and it gives me 8. Okay? Well, what is the the x-intercept? 1 point something. Yeah, we don't really know. We could try, we could guess. So, somebody guess a number. Hey, that's not guessing. Besides, that's not right. So somebody give me a decimal to guess. Nobody? 1.2. Is that the x-intercept? No, but it's close. So we can't actually see the picture very well, but we can zoom in. If you push zoom and go to zoom in, it's going to ask you where do you want to zoom in. Well, I want to zoom in as close to that number as possible. So you can see there's a little cursor. Just move the cursor to where you want to zoom in and push enter, and we'll zoom in. Okay. Well, I can also do that by changing my window. So I'm going to push the window button, and this tells me how much of the x-axis I'm looking at and how much of the y-axis I'm looking at. So I don't really need to see any negative values, so I'm going to plug in 0. How big do I need to go to see the answer? To 2, maybe? So from 0 to 2, and I can leave my y-axis where it is. This scale, x scale, tells you how often the calculator is going to put a little mark. And 1 is obviously not enough to really know in this case. So I'm going to say 0.25, and you'll watch my x-axis change. So each one of those marks is 0.25. So this is 1, 1.25. What do I think the answer should be? 1.3. So second calc value, 1.3. Ooh, that's really close. Is that x too big or too small? The x is a little bit too small. So pick a new one. 1.33. That's even closer. That's really, really close. Okay, anybody other than me sick of guessing? 1.34. Ooh, so close. That's on the other side. It's somewhere between 1.33 and 1.34. But I'm tired of guessing. The calculator will actually get that number for us. But if you're ever off the normal window and you want to get back to the normal window, there's a really easy way to do it. You just push zoom, and then in all these zooms, number 6 is standard. So we want to do zoom 6. And that will take us back to that 10, 10, 10 window. Okay. Now, x-intercepts have 4 names. Today, we're going to call them x-intercepts. Later, we're going to call them either zeros or roots. But today, we'll just call them x-intercepts. More often, they're called zeros or roots. And then the last one, sometimes we call them a solution. So if you do second calc, the second option tells you it will look for the 0, the x-intercept. So we want to pick number 2. Now the calculator is not smart enough to just tell us the answer. You have to let it know where to look. So our answer is somewhere close to 1.3. But the calculator says, you need to give me an interval to look for it. You need to tell me some number to the left and some number to the right, and then some number in the middle, and then I'll tell you the answer. So the calculator is asking for a left bound, some number to the left of the answer. I'm going to pick 0. But really, anything to the left would work. 0, enter. And now I need a right bound, something to the right. So I'm going to pick 3. And you can kind of see these 2 arrows up here. The calculator now knows to look in that little gap. So it's going to look somewhere between there to find the answer. And it says, tell me a guess. My guess is 1.3. And it says the answer is 1.33333333, which is positive 4/3. So it would have taken us all day to guess that. So we'll use the root option. All right. Number 3 says x squared minus 4x plus 5. So x squared minus 4x plus 5. Get rid of my... Okay. What is the y-intercept? 5. We know that from looking at the equation, because it's a polynomial and it ends in a plus 5, so the y-intercept is 5. What are the x-intercepts? There are no x-intercepts. So the y-intercept is 5. The x-intercept doesn't exist. Okay? All right. Next one. X. How do I do raised to the third? There's a little caret button over here on the right side. Raised to the third. Now, if you have a fancy calculator like mine, and it actually raises it to the third, make sure that you push over before you continue typing. If I keep typing, everything's going to be in the exponent. So when you get x to the third, then you push over and it'll drop down, and then you can do the rest of the equation. Somebody with the old, you have an 89. I don't want that. You have a new one. Let me look at yours. Nope. Whose calculator actually shows a caret? In the equation, it shows a caret? Yes. Okay, if your calculator does this, you don't have to put over. It automatically moved it over. Whose was this? So x to the third, I don't even remember, minus, tell me what the rest of that is. Plus 2x minus, is it 25x? Oh wait, squared, thank you. Minus 25x minus 50. Do I know the y-intercept without graphing this? What is the y-intercept going to be? Well, look at the equation. If I get rid of all the x's, that becomes a 0, that becomes a 0, that becomes a 0, and then I get negative 50. So this one has 3 solutions. How come it has 3 answers? Why did the last one, well, last one didn't have any answers, but why do you think this one has 3 answers? You typed it in 3 times. Try again. Okay. So what about this equation allows it to have 3 solutions instead of 2 or 1? It's an x to the third. X to the third can have up to 3 answers. X to the fourth can have up to 4 answers. Now they might not have any, or they might only have 1 or 2, but it can have up to 3. So, do I trust the calculator in that these answers are whole numbers? Can I guarantee by looking at the graph that they're whole numbers? No, they look like it, but really the only way to know is if you test it. If they all look like they hit at whole numbers, then they probably are, but maybe not. So let's test one just to be safe. So second calc, I'm going to go down to 0. Let's say I want to find this root here. What should I pick for a left bound? Well, negative 5 looks like it's the answer, so I need something to the left of negative 5. Negative 6 would work, or negative 7, or negative 8, all the way out to negative 10. So negative 10, or well, no, I don't want negative 10. So I'll do negative 7. What should I pick for a right bound? And I need to be a little bit more careful here. I want to make sure that my right bound does not include one of the other x-intercepts. So picking 0 is a bad idea. By picking 0, I actually create an interval that has 2 x-intercepts in it. And I want to narrow it down to 1 x-intercept. So I just want to make sure that it only includes one of those answers. So I could say -4 would work. And then my guess, and really, as long as you only have one intercept in that interval, your guess can be anything inside the interval, and the calculator will find it. So I'm going to guess -5.124, because that's what I think it is. And I get 5. If one of them is a whole number, the other two are most likely whole numbers. Okay? All right. Start working on the rest of that page. We'll talk about 6, 7, and 8 when you get there. So we'll pause this and let you work for a second. Number 6 says -8 divided by x. Well, I can't tell from the equation what the y-intercept is going to be, but I can plug in 0. So I plug in 0 and I get, what's the answer? When x equals 0, y equals nothing. This is like, was it Cheyenne we made fun of yesterday? This is Cheyenne not actually living in a city. There is a domain, 0, but there's no range attached to it. And because of that, it's not part of the function at all. So 0 does not belong to this function, because if you put it in the domain, you get no range when you plug that in. So there is no y-intercept. This graph never touches the y-axis. What about the x-axis? How far out do I need to go before I hit the x-axis? All the way out to infinity. Well, I can't actually get there, so it never touches the x-axis. So this one has no intercepts at all. All right, looking at number 7. So -4 times, is it 0.5 to the x? 1.5 to the x. Graph that. How am I going to find the y-intercept? Because the equation doesn't tell me. There's no constant in the equation. Plug in 0. So second calc value, I plug in 0 and I get -4. Where does this touch the x-axis? At -infinity. So it does not touch the x-axis. Okay? And then everybody graph number 8. Let's do yours for a second. Number 8 can be a little confusing depending on your calculator, and you do need to put the parentheses. Oh, did I miss something? Yeah, I missed. Here's a little trick. I need to put a +5 in my calculator, but if I put +5, then I have to rewrite the whole rest of the equation. Above the delete button is an insert button. If you want to insert something without deleting what's there, just push second delete, and then I'll put my +5, and it will bump everything over. And then you don't have to rewrite it. Something's not right. Oh, it should be -5? Okay. Okay. Here we go. Now, does anybody's graph have a vertical line that's not seen on mine? So let me show you this. So there's a picture of my graph. Actually, let's do it this way. And look at this one. Yeah, I'm working on it. See that vertical line? Can't really see it very well. Well, this graph is actually in two parts. It kind of looks like this, and this part is so low it's never going to hit an axis. And some of the older calculators like to play connect the dots. So as this one comes down, it tries to connect the top dot to the bottom dot and draws a line there. That line does not really exist. So if you tried to find the roots, and you can't really see that. So if you used your second calc 0 and you looked for that answer, it's going to say no sign change, which means there is no root there. So if you have a vertical line and you try to find its root on some of these older calculators and it doesn't work, that means that that line is not really there. But most of the newer calculators fix that glitch, and you don't have that problem. Okay? So your assignment today is to finish the rest of this worksheet. And luckily, you guys all have calculators, so everybody should be able to do it. What's your question? You want what? Oh, yeah. Well, I can show you how to run that. It's either way.